We can turn waste into a resource, brine into fresh water, greenhouses into food-producing oases, and the power of sun and wind into life. Millions of tons of salty waste are discharged into warm seas every day. This destroys ecosystems and kills life. But these wastes can be transformed into a source of clean water, food, and energy. 70% of all fresh water is used in agriculture. In the Middle East, India, and North Africa, survival without desalination is impossible. But reverse osmosis is only half the story. We pay for clean water with an ecological disaster. Most conventional desalination technologies, especially reverse osmosis, generate vast amounts of concentrated brine, which is discharged into the sea, damaging coastal ecosystems. A zero-liquid-discharge (ZLD) complex doesn't just desalinate water, it fully processes the brine, transforming it into heat, moisture, and agricultural resources. Greenhouses in arid regions operate at the edge of feasibility. They require stable irrigation, ventilation, and cooling. Integration with the desalination system provides water for drip irrigation, air cooling using brine, and thermal storage for nighttime heating. The result is high-efficiency, year-round production of vegetables, greens, and fruits, even in desert conditions. Thanks to the use of solar concentrators and wind energy, the system operates without external power supply and produces no harmful emissions. All resources are local: sun, air, and saline water. This makes the project ideal for resource-constrained countries with high solar potential. Why it matters. This is not just a replacement for existing technologies. It's a paradigm shift, from fighting drought to creating productive oases. It enables waste to become a resource, providing water, food, and climate control, all from a single integrated system. It's not a lab concept. The technology is already technically viable, scalable, and ready for pilot deployment. These are the kinds of solutions that build a sustainable future. A future where water means abundance, not scarcity. A future where the harsh desert is not a problem, but a possibility. Cooling greenhouses in hot climates is a complex and costly task. We use brine twice, first as a cooling fluid for greenhouses and a source of stored heat for nighttime warming, then as feed water for desalination. The fresh water produced is used for drip irrigation, fogging during peak heat, and as a source of clean water for nearby communities. The result is a stable microclimate and year-round high yields in greenhouses, along with a solution to freshwater scarcity for surrounding populations. Scale, performance, and benefits. Up to 10 tons of distillate per hour from the evaporation unit. 4,000 meters squared of greenhouses, plus irrigation and potable water supply. Up to 80% reduction in energy and water consumption. No environmental harm and minimal infrastructure costs. All components are modular and scalable. The technology is well suited for desert regions with intense sunlight, water scarcity, and access to saline water. It can function as both a large-scale agro-industrial complex or a self-sufficient module for a small village. The technologies we use are easily adaptable to local conditions and suitable for local manufacturing. We build on proven principles of thermal engineering, agronomy, and closed-loop water systems. All equipment can be assembled locally, powered entirely by sun and wind. We are ready for pilot deployment. We're not just fighting drought, we are creating a new model of water supply and agricultural production. No harm to nature, real value for the future. If you're ready for change, let's build it together.